Hello, in this video we will talk about Gauss-Jordan elimination. So recall, a system of equations can be written as an augmented matrix. So here we have a system of equations. We've got three equations and three unknowns, x, y, and z. And we can take those equations and write them as an augmented matrix. We've got 3 rows and 4 columns. That fourth column is coming from our column vector representing the constant terms. Okay, so back in the last lecture we talked about how to solve linear systems, and we did lots of different operations, and those can be broadly categorized into 3 categories. So one operation we can do with a system of equations is we can multiply both sides of an equation by a non-zero constant. So let's say multiply an equation by non-zero constant. Sometimes it's very convenient to maybe multiply the second equation by -2 and add them together so that you can cancel or eliminate a variable. The second thing we can do is we can add 2 equations together, and we often did that to eliminate a variable. And the third thing that we could do if we wanted to would be to interchange 2 equations. And I'll abbreviate that, equations. So those are the operations we can do with linear systems, with systems of equations. And what we want to do is we want to think about those same operations and how they would be done, how they would be executed if we're working with a matrix. These operations will be called elementary row operations, and the reason they're called that is because we don't have any equations, we really just have rows of a matrix. All right, and so we're going to have an analogous 3 elementary row operations. So over here in an equation, if we multiply an equation by a non-zero constant, that's analogous to multiplying any row by a non-zero constant. And let me make a little more space for us down here. Number 2. We can add 2 equations together. That's the same thing as adding 2 rows together in the matrix. And thirdly, since we can interchange 2 equations, that's the same idea as interchanging 2 rows. All right, now let's think about the goal. How do we know when we're done? Over here, when we're working with these equations, our goal is to find x equals, and whatever its answer is, y equals, and z equals. Our goal is to solve for x, y, and z. Over here, in terms of elementary row operations, our goal would be to get the coefficient matrix to look like the following. We don't care what we get over here for these constant terms, but if we can get the coefficient part of our matrix to have 1s down the main diagonal and 0s everywhere else, what this would give us is this matrix would give us that x, y, and z. This would give us that 1x equals whatever this constant is over here. It would tell us that 1y equals whatever other number we get in the second row. I'll just put stars in there for now. And 1z, that would tell us that whatever we get in that third row is our answer. And so that's the same idea here.